Graphing tangent of x. So we've done sine and cosine. Tangent of x, however, doesn't have a ratio of a side length with 1. It's actually taking the y value over the x value, or sine over cosine. And so we're going to have to do a division problem in order to get values out for my side ratio when I plug in radian measures for x. So let's take 0 for example. In my unit circle, I know this is going to be y over x. So y over x, if I have 0 right here, this point is 1 comma 0. So I have 0 over 1, which is just 0. So I know at 0 radians, I'm going to get out 0. So then if I move on over here to, let's say, pi over 6, I'm going to take my y value, 1/2, over my x value, rad 3 over 2. 1/2 over rad 3 over 2 is just 1 over rad 3. So I can plot my value there if I want to. It's in between these two. Just be about there. And then here, pi over 4, I just have rad 2 over 2 over rad 2 over 2. Anything over itself is 1, so doing that division I get 1. Here at pi over 3, I can see what's happening is I'm taking rad 3 over 2 over 1/2, flip the fraction and multiply, and I have just rad 3. Now something really interesting happens at pi over 2. I have 1 over 0. Well, I can't have anything over 0. So at certain places where my x value is 0, I'm going to have places where this can't exist. So right here at pi over 2, my function can't exist because I can't have that 0 in my denominator. I can't get that out there. So at pi over 2, and again I find my x value is 0 at 3 pi over 2. In fact, any odd power of 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, I'm going to have that happen where I have a 0 in the denominator because my x value is 0 and I have y over x. So I have it not existing there. When I go to 2 pi over 3, right over here, I find that I've got negative rad 3 over 2 over 1, oh not negative, rad 3 over 2 over negative 1/2, which gives me a negative rad 3. And that's more than 1. So notice I don't have my limits like I did with my sine and cosine. I don't have an upper limit of 1 and a lower limit of 1 because I'm dividing those two sides, that y and the x. Now when I put in 3 pi over 4, I have a negative rad 2 over 2 and a positive rad 2 over 2. Positive rad 2 over 2 over negative rad 2 over 2 just gives me a negative 1. Anything over itself is 1. And 5 pi over 6, I'm seeing that same value except for negative in 5 pi over 6. I'm seeing 1/2 over negative rad 3 over 2, which is just negative 1 over rad 3. And then at pi, I see I'm getting back to 0. Now when I continue along this axis, I notice I'm going to start to get my same values because tangent, remember, is positive in this quadrant because I have a negative and a negative. And then going over to this quadrant, I'm going to get some negative values. So really it's repeating instead of every 2 pi, it's repeating every pi. And so if I look at what some of these things look like, I can see this kind of curves up here. Oops. And this is going to kind of curve up. I didn't really draw this great. And this is going to curve up. It's going to approach this line. This is an asymptote. And if I were to graph negative ones, I can see I'm getting down here. I would come down here and approach negative pi over 2. This is negative right here. So I would encourage you to graph some more values, especially as you get really close to pi over 2 to see what might happen. So you might want to just try some values as you get to negative pi over 2 or to pi over 2. So here I have pi over 4, and I could have getting closer and closer to pi over 2. So pi over 4, I have pi over 3, I could have pi over 2.1. See what's happening as you get closer and closer to pi over 2. So see how what's happening to your tangent values as you do that division. And you can try some of those on your calculator. You don't have to use radians. If your calculator's in degrees, you want to see what's happening as you get closer and closer to 90 degrees. So maybe try tangent of 89 degrees. And as you do that, you'll see that you're going to get really big values for tangent because it's going to be approaching that line. So, and if you try tangent of 90 degrees on your calculator, you'll get an error. You could also try, if it were in radians, tangent of pi over 2. So I encourage you to try that out just so that you can prove it to yourself that this is what tangent looks like. And notice it is a periodic function and repeats every pi. So it doesn't go to pi, it goes every pi, and it repeats this kind of curvy line. This isn't really a very good example of it. Let me curve this a little bit more. Whoops, and it doesn't cross that asymptote. So that's kind of what tangent looks like. Your graphing calculator could probably do a much better job than I can.